Well, let's turn to those weather impacts now as we are tracking the potential for some severe storms this morning.
That's right, Chris. You say there's a lot to this storm that makes it potentially dangerous.
Yeah, and it's in multiple levels of the atmosphere, as I'm going to show you. But number one, the biggest threat that we're going to have is for damaging winds. And there's also this area of red that has these lines through it. That's a significant severe threat. So those areas could have a better chance at winds over 70 miles per hour, which is close to hurricane strength. And our tornado potential is much higher the further east you go. And we're going to explain why. First off, this event is technically called a QLCS. We've mentioned this a bunch of times. 90% of all the tornadoes that we see here in North Carolina are from events like these. So this stands for quasi-linear convective system. Simply, that just means a line of thunderstorms that has these kinks and bends and twists that allows for spin-up tornadoes within them. They move fast, they form fast, they're short-lived, and they're most common. So that's why I want everyone, as they might be looking at the radar, when you have a tornado warning, oftentimes in this event, the tornado already happened. It just doesn't have a potential for it to happen again. So as that line of storms that moves through, and Larry is going to show you the exact timing, that line could have gusty winds over 60 miles per hour or a spin-up tornado that could range from 65 to 85 plus. So keep that in mind. Stay weather aware as it's moving through. We're already seeing signs of this. As I mentioned, my loose definition was a line of thunderstorms with some kinks and bends and twists. This is called our velocity scope. So this physically is looking at how fast the storms are moving and the potential winds that these are bringing. Now you have to do some math factoring in how far away the radar site is, but this shows the wave to the atmosphere a little bit further up. So we are actively seeing those twists and bend because the amount of wind shear that we have associated with this, and some of those winds are measuring 60 to 70 miles per hour. Now when they mix to the surface, that's likely a little bit closer to about the 40 to 50 mile per hour range, but we have the energy there. Speaking of, that's exactly what vorticity is. Anytime you show you a map like this is a little bit more complicated meteorology. These deep purples represent the amount of energy to the system, and there's a lot of it with this. Now the winds are coming from the south right now, a really strong breeze. You notice if you've been out and about, but what's going to be happening through the course of today, the winds are going to be in different directions. So as long as you have those winds coming from the south and then winds coming from the southwest and west, that's wind shear. So that's ideal, what we call directional wind shear, and why we have a risk for some of those tornadoes. As long as you have kind of that 90-degree angle that we do have up to about 18,000 feet, that's going to allow this line to twist, to bend. That's why we have an elevated tornado risk, but the time of day helps us. When you get to the afternoon, that's peak instability. Luckily, the Charlotte area sees it a little bit earlier in the day, but Larry, that's why we have a much higher potential for all of the above the further east you go.